These are solving simultaneous equations where one of them is a quadratic. I know this is a quadratic because it has squared terms in. This is linear because it doesn't have any powers. Now, when you're asked to solve simultaneous equations where one's linear, one's quadratic, you need to substitute the linear equation into the quadratic. And the point in that is because we want to get rid of one of the variables. I can't solve anything as long as there's two variables. I need one variable. So what I'm going to do is take this linear equation, and instead of having x plus y equals 2, I'm just going to rearrange it. And I want y as the subject. So I'm going to have to subtract x from both sides of this, which will leave me with y equals 2 minus x. And what I've ended up with here is a little expression for y. So I can substitute anywhere there's a y with 2 minus x. So I'm going to go ahead and do that. I'm going to bracket it off because I'm keeping those together because they represent y. I don't want them getting lost. I'm going to start now by writing my quadratic out. That was x squared plus y squared equals 9. Now, I don't want the y squared there. Instead, I want x squared plus my value for y, which is 2 minus x. And that is now squared. And that's equal to 9. So look, I've literally lifted the y away and dumped 2 minus x in instead, because that's what I rearranged y as being equal to. Now this is done, hopefully I can spot the first thing that needs my attention is this double bracket here. 2 minus x squared is exactly the same as 2 minus x multiplied by 2 minus x. So I'm going to expand those brackets out. 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. Negative x times negative x is positive x squared. I'm going to neaten this up. I've got a positive x squared, I've got negative 4x, and I've got a positive 4 on the end. So that can now be dumped back in at that point. So I had my x squared there from earlier, and now joining that party, I've got my expanded brackets. So I've got my new x squared, my new minus 4x, and my constant of 4. And I know that that was originally equal to 9. At this point, I'm going to collect and simplify again. X squared and x squared leaves me with 2x squared minus 4x plus 4 equals 9. I can't solve anything if it's not equal to 0. Therefore, I need to subtract that 9 from both sides, leaving me with 2x squared minus 4x minus 5 equals 0. At that point, I've got a quadratic equal to 0. I can use that to solve for x. You should pick up on the fact that it's the quadratic equation we need to solve this, where the coefficient of the x squared term is equal to a. So a is equal to 2. B is equal to negative 4. And c is equal to negative 5. So if I'm not familiar with the quadratic equation, I can copy it out the front. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. And now I'm going to substitute my values in and calculate them. So x, I'll use a post-it. So x equals negative b, and b was minus 4, plus or minus the square root of minus 4 squared, minus 4, a was 2, and c was minus 5, all divided by 2 lots of a, which was 2. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Then I split that and I do one as a positive and one as a negative. and that will end up giving me, when that's put in the calculator, you'll end up with x equals 2 plus the root of 14 over 2, or x equals 2 minus the root of 14 over 2. When I put that into my calculator, I'm going to end up, or when I press SD even, I'm going to end up with x equals 2.87 or x equals negative 0.87. Now what I do is I take both those values of x, substitute them into one of the original equations and solve for y. So now I have my two solutions for x, I can find what y is at both of these points. So the original equations, there's the quadratic one. I don't want that, I want the linear one. And let me get another post-it here. Because what I'm going to do is say when x equals, and then the first of my solution, which was 2.87. So when x equals 2.87, then I'm going to substitute it into this equation. X plus y equals 2. 2.87 plus y equals 2. I want to find what y is, so I subtract 2.87 off both sides. Y equals 2 minus 2.87 leaves me with negative 0.87. So that's one solution for y. And then the other one is when x equals negative 0.87. I'm going to substitute that in. So I've got negative 0.87 plus y equals 2. I need to add 0.87 to both sides. And that leaves me with y equals 2.87. So I'm going to finalize and summarize my solutions. X equals 2.87, y equals negative 0.87, and x equals negative 0.87, y equals 2.87. And that's completed, and my answers are put in the correct place. Here's another one for you to have a go at. Quadratic equation, linear equation. Solve them simultaneously. Don't be mistaken by thinking you have to rearrange to get y equals, though. It's perfectly acceptable if you wish to just put x equals that expression instead of the x there. Press pause, have a go, press play when you're ready for the answer. Alright, I'm going to be as quick as possible. So as I said just now, I'm going to take that to be x. So I'm going to rewrite my quadratic out, but instead of having an x there, I'm going to put my expression in. So 2y plus 6 squared, so that's there instead of my x, plus y squared, which was already there, equals 36. So you can see there's no x's now, only y's. That means I'm able to solve this. Alright, first things first, I can see that I've got a double bracket here, or what will be a double bracket because it's a bracket squared. So first thing I'm going to do is expand that, and I'll do that over here. So I had 2y plus 6, 2y plus 6. I'm going to expand it. I'm not going to cut any corners. 2y times 2y is 4y squared. 2y times positive 6 is positive 12y. 6 times 2y is positive 12y. And 6 times 6 is positive 36. I'm going to collect and simplify. That gives me 4y squared plus 24y plus 36. Now I'm going to replace that back into the original here. So I had 4y squared plus 24y plus 36. So that came from the expansion of my substituted bracket. I can't forget that I had this positive y squared from earlier, and that equals 36. Now I'm going to collect and rearrange these. So 4y squared plus y squared is going to give me 5y squared plus 24y plus 36 equals 36. In order to solve any kind of quadratic, I need to have it equal to 0. So I need to subtract 36 from both sides. So that gives me 5y squared plus 24y. 36 and minus 36 cancel down, and that leaves me with 0. So from here I can go ahead and solve this. I probably wouldn't use the quadratic equation here because I would factorize. However, I'm going to do it with a quadratic equation because that's what we've been looking at. So 5y squared plus 24y equals 0. I need to start by saying what a, b and c equal. So here a is the coefficient of the squared term, so a equals 5. B equals 24, and it's a positive 24. And now C equals, we don't actually have a constant there, so C is going to be 0. So A is 5, B is 24, C is 0. I'll substitute that into the quadratic equation. So instead of starting with x equals, I'm going to start with y equals. So y equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. I'm going to dump my values in. Y equals negative 24 plus or minus the square root of 24 squared, and I've been sloppy, I haven't put my brackets on. Let me add them in there. So negative 24 plus or minus square root of 24 squared minus 4 times 5 times 0 divided by 2 lots of 5. Now here you may spot that negative 4 times by 5 times by 0 is going to come to 0 anyway, because anything multiplied by 0 will be 0. So I'll end up with negative 24 plus or minus the root of 24 squared. If that's too much to deal with, you can just literally put that in your calculator and you will come out with the correct answers for the positive and negative solutions. So that, when I put that in, I end up with either y equals 0 or y equals negative 4.8. Now I've got my two values for y. I can substitute those in to the original linear to get my values for x. I'm not going to do it here. I'm just going to write that x would end up being equal to 6 when y is 0. When y is negative 4.8, x equals negative 3.6. So there's my two possible solutions. This question isn't a quadratic, but it is a simultaneous equations question hidden in a chunk of text. Press pause, have a go at this. I'll give you a clue in that you need to make two equations which are simultaneous from the problem and then solve them. Okay, so I'm going to start by writing my equations. The cinema ticket sells adult tickets and child tickets. I'm going to call adult tickets X. You may wish to call it A, that's fine. And child tickets, I'm going to call Y. So the total cost of 3 adult tickets, so that's 3X, and 1 child ticket, so 1Y, is equals £30. Also, the total cost of 1 adult ticket, so 1X, and 3 child tickets, so 3Y, is £22. Work out the cost of an adult ticket and the cost of a child ticket. So essentially, find the value of X, find the value of Y. In order to do this, I need to eliminate one of the variables, either X or Y. I'm going to choose to eliminate the Y variables. This is equation 1, that's equation 2. In order to be able to eliminate them by taking them away or adding them, I need to make sure that the coefficient is the same. In order to get the coefficients the same, I need to get that one up to 3y. So I'm going to multiply this equation by 3. And that's every term in this equation. I don't need to times this by anything because I want the 3 to remain there. So 3x times 3 is 9x. 1y times 3 is 3y. 30 times 3 is 90. Don't forget to times the 30. Most people do that. So what that gives me now is a new equation. I'll call it equation 3. I need to work out how I'm going to eliminate those 3y's, a positive 3y and a positive 3y. If I added these together, I'd end up with 6y. That's not what I want. If the signs are the same, I need to subtract the equations from each other. So I'm going to make a note here that I'm going to take these away. I can do it either way I want. I can either take this number from this one, or I can take this number from this one. I can see that equation 3 has the biggest numbers throughout. So I'm going to say here, I'm going to do equation 3, take away equation 2. So 9x, take away 1x, leaves me with 8x. 3y, take away 3y, leaves me with no y's. And then 90, take away 22 is going to leave me with 68. So here I end up with 8x equals 68. I want to get x on its own, so I eliminate by dividing by 8 on both sides. So that then tells me that x is equal to 8.5, or because we're dealing with money, it's £8.50. So now I found the price of x, which remember was an adult ticket. I can substitute that back into one of the equations in order to find a child ticket. I'm going to choose to substitute it into this top one, 3x plus 1y equals 30. I'm choosing this one because y doesn't have a coefficient, so it's easier for me to find at the end because I don't have to do any division. So I'll start by writing the original out, and in fact I'll tell the examiner what I'm doing. I'm going to substitute x equals £8.50 into what was my original equation 1. So I'll write the equation 1 out. It was 3x plus 1y equals 30. And now instead of an x, I'm going to put £8.50. So that's 3 lots of £8.50. Note how I'm using the brackets for the substitution. Plus 1y equals 30. Well, 3 lots of £8.50 is £25.50. Plus 1y equals 30. I want the y on its own. Let's subtract the £25.50 from both sides. That leaves me with y equals 30, take away £25.50 is £4.50. And y represents my child price. So now I just need to write the values in. Adult ticket costs £8.50, child ticket £4.50.